Okay, so this is a project. Essentially, what it's. Sorry, take it when I ask you to take it. Okay.
Mm-hmm.
This project is essentially simulating lighting in a room and temperature in a room, and I've used a third LED in this system to represent a fan or a heater turning on in a home or in a room when the light and the temperature in a room reach an undesired level. So right now we have so right here we have a photocell resistor. My finger currently is holding a thermistor sensor, and both of these are hooked up with a 10K resistor going into a comparator op amp. Now on the positive side of the comparator op amp is our photocell sensor. That's going into the positive input here of this comparator. On the other side, we have a potentiometer, a 10K potentiometer, with the wiper set in the middle, essentially giving 5K resistance on both sides of the potentiometer. And so the output here is about 2.5 volts going into the negative end of the comparator. So when the resistance is low here at the photocell, this light will stay on. Here, I'm going to let go of the thermistor. The temperature is going to change, and that's going to affect that light, but I want to show here. So we can pull this. So right now right here on the negative output, we have about 2.5 volts going into the negative part of the comparator. And in room light, we're putting out about 3.2 volts going into the positive part of the comparator. So because it's hitting the higher rail, we have the output feeding out to this to a 200 ohm resistor in series with the red LED. So because of that, the red LED is on. Now, as I cover the light here, the LED goes off because we're putting out about putting out about 2 volts, 1.8 volts. So because that's below the 2.5 volts on the other end of the comparator, the light goes off. So as you can see, whenever we cover it, it's just through the comparator op amp, it'll change the output of the voltage will change. So on the other end of this, right now we're getting about 3.4 volts, which is plenty of voltage to turn on the LED. When I cover it up, we're not getting much voltage at all, a couple millivolts. So that's that side. Now on the thermistor side, if we have the temperature, if I hold my finger on increasing the temperature on the thermistor, right now we have about 2.6 volts going up even more. And again, on the negative output here, if you go look at the negative, going into the negative input of the comparator, it's about 2.5 volts. Because again, we have here a 100K resistor, or 100K potentiometer set in the middle, so about 50K on both sides. And all of this has a 5 volt source. There's 5 volts going into each one of these components. That's something I neglected to mention. So 5 volts going to the potentiometer gives us about 2.5 volts. Now, this is the voltage again with the temperature rising. So the resistance is going down, so we're getting more volts. Now, that LED is turned on when this is the case. So if I take my finger off, the voltage is going to go down. Now when it goes below 2.5 volts, that LED should turn off, because again, we have a comparator op amp, and when the voltage is lower on the positive input, there you go, the LED turns off, because now we're only giving about 2.4 volts. The negative output is higher, so we're going to the low rail. And on the output here, going into the LED, we don't have any voltage. So basically what this does is, now in the center we have a NAND gates system op amp. So what I've essentially done is I've negated the same output that's going here into the LED at the thermistor. I'm using these wires to negate that input, and that's going in here to the NAND operation. So basically I have 2 inputs and then an output. Here I have again 2 inputs and an output. So whatever I get here from my output, I'm negating that going into this. So essentially what I'm doing is I'm saying, well, I negate the inputs, and I take the output of that, and I negate that output as well here. And I've set it up to be that it's only when both of these LEDs are off that the blue one turns on. So it's only when the temperature is bad and the light is bad that the motor will turn on. So as you can see right now, this one LED is on. If I hold my finger here, they're both on. If I cover the light, this LED goes off, but that one's still on, so the blue light is off. Now it's only when they're both off, so now the temperature is going to get cold and the light is bad, that the blue LED will turn on as soon as the temperature gets low here. And now we have that. Again, if I ever take my finger off, LED will turn off. So essentially I've created a NOR output. I've created a NOR gate, rather, negating 3 different NAND gates. Going into a 4th NAND gate will give me a NOR. So that's pretty much it.